Well, hello, Fruitport High School chemistry students. Welcome to today's lesson, which is a completely optional lesson for the end of semester. I like to give extra credit when you do extra learning, not extra work. So if you can learn this lesson, it's a little challenging. If you do the assignment and prove that you learned, I'll give you some extra credit. So today's assignment is about predicting the products. Remember, reactants are what's before the arrow, and we can try to predict what the chemical compounds are going to be after the yields arrow if you can kind of put together a lot of the things that we learned in this semester of chemistry. Okay, so so let's just kind of take a few quick little notes and samples to see how it's going. Right, the biggest thing for doing this assignment is being able to predict what kind of reaction will occur with not seeing the whole reaction. So for instance, we probably learned something like this, right? Aluminum plus oxygen can turn into aluminum oxide, and this is called a combination reaction. But if I just saw the aluminum oxygen reactants, could you still know it's going to be a combination reaction versus those other ones, right? If you just saw nitrogen plus oxygen, if you just saw this, could you predict this is going to be a combination? All right. And if it is going to be a combination reaction, then you just combine the compounds to make the product. Sometimes you got to pay attention to like crisscrossing with positives and negatives. So again, there's two small things. Well, there's no organic compound for combustion. There's not enough for a double replacement or a single replacement. And so this is how we can know it's going to be a combination reaction. Okay. The other one is what we call the decomposition reactions, and that's where we only have one substance before the arrow, only one reactant. And so we learned in some notes that this will break down into some smaller compounds. One thing turning into two things is called decomposition or analysis reactions. But if I gave you a big substance, maybe NaHCO3, and that's all I gave you, there's nothing to combine with, there's nothing to do a replacing with, so it must be a decomposition, and you can then predict what's going to happen. Decompositions are the hardest ones to predict, by the way. You will not see those on the homework, okay? Can you tell a single replacement reaction from just looking at the substances before the arrow? And you can look for an individual element and look for a substance that is combined in a pair. So if you see a single element and a pair, this would be a cation paired up with an anion. And we have a single, you could be like, whoa, it's going to do a single replacement. Okay? And we have a different single and a different pair up. The lithium's now paired with the oxygen. Could you just see this compound and realize that it's going to be single replacement and then try to pull off a single replacement? This is challenging. When you do for the homework, when you do the single replacement, do not combine cations together. Iron's a metal, which means it's positive. Copper's a metal, which is positive. Chlorine's a non-metal, which is negative. When we go to do a single replace, will the iron bond to the copper? It will not, because they're both positive. In nature, you should have learned that two positive things don't come together, they repel. But the iron will bond with the chlorine because a positive bonds with the negative. You got to watch out for that same phenomenon in our double replacement reactions, okay? Double replacement reactions where we have two ionic compounds with like something positive and something negative in a compound combining with something else positive and something else negative. And then we do a flipperoo. In this case here, Sodium's positive. It's going to find something new to bond with. Will it bond with the magnesium or will it bond with the oxygen? Well, since sodium is positive, and we always put the positive first and the negative second, positive and negative. We do not want sodium and magnesium to predict a combination because that's against nature. And in this case here, if I looked up the charges and did a crisscross, I need to put a 2 there. And that means magnesium is left with some chlorines. Again, magnesium's positive 2, chlorine's negative 2. I used the periodic pattern. 1, 2, 3, skip -3, -2, -1, 0. And that's how I could come up with the numbers for the crisscross. So a double replacement sometimes looks good. Maybe I have LiNO3. Let me throw a little polyatomic ion in there for you with the CaSO4 and some more polyatomic ions. Could you see that we have 1, 2, 3, 4 kind of, characters to pull off a double replacement? If you can do the homework. And combustion reactions are always easy. If you see something organic, the key element for organic chemistry is carbon. Maybe you got a C4H10, and you always set it on fire with oxygen, and you always make carbon dioxide and water. So if I gave you a C6H12O6 and was going to burn it with some oxygen, you can predict you always make carbon dioxide and water. Okay, so maybe this makes a little sense to you. There is a little bit of complexity with this because you'll have to remember things like naming ionic compounds. When do we crisscross? When do we not? Are we going to need parentheses around polyatomic ions? But that's how you'll get the most extra credit. If you can predict the products and get really close, that will give you some partial extra credit. So you can do that Monday and Tuesday at home because Wednesday is the day that I have to have the grade book done. So I'd like for anything to be submitted. You'll see an assignment in Google Classroom, and you can do all the work on another piece of paper, and you can share that with me. All right, cheers.